So is it this one?
Guys, I think we're finally ready to get the show on the road. Now, don't be afraid to come to the front. Nothing bad will happen to come to the front. We don't have any EDIs here, so these are, well, I can't promise anything. I can't make any guarantees, so be brave. Hey, come on, guys. Come on out. I'm really pleased that so many of you turned up. The weather conditions are so horrendous. I mean, what?
Stormy weather.
Like several feet of snow out there. So you managed to negotiate the snowflakes. Sorry, I don't think I'm standing in the right spot. There we go. All right, everyone got drinks ready to go. So we've got 3 speakers for you this evening. The first 2 are here in person. The third is speaking remotely in I think he's in London. And apparently he's telling me the weather conditions down there are seriously bad. It's, I think he must be at home because he was talking about his neighbour's, I think it was a greenhouse, sort of doing cartwheels through his garden or something. So apparently they've got very, very high winds down there. So hopefully the connection will be fine and it'll go seamlessly. It's the first time we've held an IOT Scotland meetup at this very fine establishment. I feel like I'm coming home because I'm kind of Edinburgh Uni alumni, I suppose. I was based in Appleton Tower for a couple of years, which is that very tall building. Is it that way? Over there, in that direction. You couldn't miss it on your way in. That beautiful building. Actually, it's a lot better looking now than it was. It was horrendous. Beautified with a new cladding and so on. So I'm very grateful. I feel like I'm kind of coming home in a weird kind of way because we're a pop-up. We, as you know, we kind of travel around and we're always looking for new and exciting locations around Edinburgh to host our events. So we're very, very privileged and pleased and happy to be in the Edinburgh University informatics building today. So Thank you so much for agreeing to host us and for co-organising the event. So would you like to say a few words, Dave?
Just a few actually, so I'm going to keep you long, but I'm Simon, and I guess it's our pleasure to host this IOT meetup, and hopefully this will be the first of many. My name is David Richardson. I'm with the School of Informatics, and as Simon said, we've got a number of different things happening at the moment. So the Apple Tower, which Simon and many other companies were part of, is actually coming back on stream at the end of this year. We're refurbishing that at the moment. Behind us, we've got the new base centre opening up, which actually joins onto this building. But we've got a number of different groups, from designers to informaticians to mathematicians. And we've also got space for corporate research and development groups coming in there. And the theme that we're really pushing around with the base centre is the interaction between people, data and systems, and obviously IoT will play a big part in that, along with all these other new enabling technologies that we're seeing popping up. We've got a big interest in robotics, and we've got a blockchain initiative that we're just about to kick off as well. This week is quite timely because we've launched an IoT week, and this is the first LoRa Challenge Week that we've launched using a new LoRa network that was spun up within the university. We've got 4 teams with challenges from City of Edinburgh Council, Transport for Edinburgh. We've got festivals involved in that. And we're also very fortunate to have PyCon sponsor that event. And Fred is here tonight from PyCon, and you might bump into him earlier on there. And I also learned earlier on that there is such a thing as a LoRa-enabled snow sensor. So that's maybe something we all need. Just like to point out the bathrooms, if anybody's looking for them, around the corner. We've got a fire exit over here, and just out the main entrance where you came in. No drills planned tonight, so if there is anything, please make your way to the exits. That's all I want to say. Welcome to the Informatics Forum, and look forward to a great evening. Thank you. Simon.
So, this is the bit I like to call a forum. It's really important. We're building a community. We've got about 1,000. A safe place for you guys to out who are kindred spirits, who are into the same sorts of things that you are. And as a result, this is your opportunity to reach out to other members via the live stream or in person to talk about projects you're involved with. Maybe you're working on a kind of hack and make project and you're stuck and you need assistance, some help. You just want to show it off. You just want to say, this is the kind of project I'm working on. I've got a Raspberry Pi, I'm hacking a smart home device. Or maybe you're thinking of starting an IoT company, or maybe something. Well, what was it? Raspberry Pi. Welcome, coming in. Hi, Robert.
I'm raised about 3,000 quid. Just not the first production run.
Yeah.
I'm planning on
Very cool.
I've sold mine. It's been done for about 2 years now, so
2 years. Okay, get a move on. What's taking you so long? Dr. Patrick Hickey. So we were on the same entrepreneurial in residence program, weren't we? That's what brought me to Edinburgh almost 10 years ago now.
10 years, yeah.
Yep. So it's a shame Dr. Tim Willis wasn't here because he was again one of the original members, co-organisers, but he's in Tokyo at the moment. Lucky him. So, Simon Chapel, where are you? I know that you would. There you go. You want to say something about a LoRa project that you're involved with? Is that right?
At the university member of the foreign gateways, LoRa gateways, one of the things we want to do going forward later on this year is try to understand how we can enable other people to be able to use that network. fantastic devices that the Python guys have created. Which is
A
really
previous
good response.
sponsor, so
Multi-communications devices, so they do LoRa, Wi-Fi, and Bluetooth, so that enables you to create some really interesting applications. So we've been doing some pretty cool stuff with that. But we're also interested in how we can bring the community together in Edinburgh and further afield, and how people can participate in that network as well. So if you could you may have heard of something called the Things Network. We're also running the same software installation as they run the Things Network, and so we're interested to understand how we can interoperate the Things Network devices as well. So if anybody's interested in participating in that network, both to put register devices, to want to run applications, please come and see me. And if you want to spin up a gateway in your own house or office or whatever, that would be great to hear about too, to understand how you want to be able to mesh that.
excellent. Thank you, Simon. Gary, you've been actually using the Things Network, haven't you, for your project? Easter Road. So, what is the deal? Can anyone kind of log on to it, or? I was going to ask you as my next question, what's the range? But I know Sergio's going to be talking about the range of your LP-WAN you've been...
Yeah, it's a Things Network.
Okay.
If someone has a device that's
Okay. So the best way to describe it is it's like half the G Wi-Fi connection. Kind of. But for devices rather than logging in.
really low band.
What, like 1990s dial-up?
Not even...
56K.
So the
US robotics.
So the burst can be quite quick, but you're looking at, I mean, the recommendation for the Things Network, if you're following their standards, it's something like 8 bytes is a packet, and you can probably get away with one of those every 15 minutes.
Wow.
So I'm using it for flood sensor data and stuff like that, but
Okay.
you're not sending, you could send a very short text message, but
Yeah.
that's about it. You're not sending live video or audio or photos or...
No, of course not. We'll bring on 5G for that. But I'd just be interested, it's not really probably a conversation for now, to know the differences between, say, LoRa and Sigfox or NB-IoT or Ingenuity or any of the other sort of low-power wide area networks in terms of latency and speed. But like I said, it's probably a conversation for another time. Anyone else, would you like to stand up, introduce yourself to the room, and make your announcement?
Hi guys, my name is Michael Barry. I'm an emergency medicine doctor here in Edinburgh, also an Edinburgh alumnus. I know this area mainly because Potterrow has a man called Big Cheese. You may know that through an Edinburgh alumnus. But I'm also a software developer. In the last year, I've got a couple of different ideas. I'm working on an application with Professor of Cardiology at the Royal, which is just kind of coming to close at the moment. And I'm also looking at a few other ideas. I'm looking scale. So if you have any interest in those areas, or you know someone that might, it'd be great to have a chat.
So there's another Gary who is an ethical hacker. Is he here? He did RSVP. Ooh, no show. So we've got, I always estimate around a 50% no show, but typically get between 20 and 30%, which is not bad. But because of this horrendous weather we're having, perhaps that's the reason why we physically couldn't make it. So unfortunately, there's a guy called Gary, I'll connect you. He's an ethical hacker at Napier, I think. Really sharp, really smart. And great in terms of the security side. If you're dealing with patient data, which I think you are, possibly.
Yeah.
Okay, yeah, you don't want to get that hacked. So that's kind of plus you've got a GDPR nightmare, impending nightmare to consider, which is going to be just this data protection regulation introduced by the EU that's going to be kicking in mid-2018. So if you get your data hacked and you're responsible, there are harsh penalties.
20 million euros.
Huh? Yeah, 20 million euros or 4% global turnover. And And if you are hacked, you've got to report it within 24 hours. And anyone who's hacked is entitled to sue the company. So, for example, TalkTalk, if the GDPR had been enforced, I think they would have been fined around 300 million. My concern is that a lot of early stage technology companies who of course will be planning to deal with data with consent and permission of their customers, if they slip up and they're hacked, it could take down the company. Or they try to raise money and a VC will say, well, if we invest in your company, can you guarantee you're not going to fall foul of the GDPR?
Well,
and of course they can't offer 100% guarantee.
That seems fair enough.
What seems fair enough?
Very important that companies actually take this as very, very seriously.
Oh, absolutely.
And if it takes legislation, no, they haven't. TalkTalk didn't take it seriously. I mean, TalkTalk had been hacked 2-3 years before and been notified that they had been hacked, and they did nothing about it. So, they should have been fined, whatever. And so other companies...
Yeah, but to take down a company, I think, is a bit harsh. And what you're going to do is you're going to have hacktivists targeting companies to intentionally hack them and take them down. And there are certain companies will be so, I think, badly affected that they will potentially go out of business, or it'll severely damage them because they're targeted. So I think I think that it's too draconian, and it is designed to put the fear into Facebook, Google, and Amazon. But those guys are untouchable, so it's not going to affect them at all. The ones I think are going to be affected are SMEs, charities, government institutions, family-owned businesses, and startups are going to be very vulnerable. So I'm not a fan.
Customers will be wrong.
But I suspect there'll be a reasonable defence. So, if you've got reasonable security at some level, then you'll be okay. That'll be defence.
But you've got to have that reasonable and putting the fear of God into people so they have that reasonable.
Exactly.
Yeah, but post-Brexit, the UK will probably become a safe harbour. There's always a loophole around these things. Anyhow, so rather than a debate, I love a good debate, you know what I'm like, I can go on all night long. We do actually have 3 speakers to get through, so are you ready? Everything's set up?
Yep.
So could we have a round of, sorry, no other...
just one quick one, sorry. So my name's Rob, from a company called E-Technology Wi-Fi. So we're the guys behind the free public Wi-Fi network in Edinburgh. So currently we cover around, I think about 1.5 miles square in the city centre. We have a number of kind of key areas of network hardware deployed throughout the city centre, and we're quite open to conversations around anything that might sit on that network. It's an open kind of platform as such in terms of conversation. So if anyone wants to grab us afterwards, feel free to do so.
Sounds good. Excellent. Thank you very much. Thank you so much to our speakers and to our sponsors, Edinburgh Uni Informatics. So our first speaker, are you ready? Okay, excellent. So, Matthew, you're ready? So you're
still a PhD because I'm wrapping up.
Fantastic. Okay, over to you. Thank
you. Thank you, Simon. Thank you, David, for putting together the event. Both of you, of course. And today I'm going to talk about my research, which is covering context detection using mobile devices, primarily with smartphones. You all carry it in your pocket. And I know this is a very dividing topic. We had previous meetups where we're raising awareness of how dangerous it is to upload so much data into the cloud and what that can lead to. But at the same time, we cannot neglect the benefits that we get by taking advantage or leveraging the sensor data we can collect with our devices. So I hope that my research is going to bring a bridge between these 2 aspects. So, a few key takeaways from this presentation would be that sensors on smartphones and wearable devices in general are useful to detect very complex user context. And some of the contexts that I'm going to talk about are indoor localization, indoor-outdoor detection, and activity recognition. And finally, I'm going to conclude with a vision of how context detection can be used in real-world Okay, but first quiz for you guys. This is the representation, the signal of acceleration from a smartphone. Do you know what activities this represents?
Running, jogging,
It's walking, yes. The bus? Is it? No, it's actually walking, indeed. What about in this case? And don't think just as activities themselves, it can also be the signal received from other interactions around the users, other physical phenomena happening. So, do you know what this one would be?
Is it volume, noise?
No, it's the signal from accelerometer.
So it's a car?
Car? No, close. So it is indeed a transportation vehicle. Nope.
All right.
Bicycle?
Nope, nope.
Roller coaster?
It's actually the elevator. Exactly, it's a transportation mode. When the elevator starts going down, you have a descending peak of the acceleration when the elevator starts, or the lift, we call it here in the UK. When the lift starts moving until it reaches a constant speed here, so it first accelerates, in this case, it decelerates because it's going downwards. And then coming to a constant speed while moving between floors. So looking at the distance between the peaks, you can actually determine the number of floors that the user has traveled. And of course, you can have it, yes, so it's the elevator going down, and you can have it in the opposite direction when the elevator is going up. There are a lot of noises when there's a lot of noise when the elevator starts moving, but that can be easily filtered out. This is the raw signal from the accelerometer. Okay, what about in this case? This, to give you a hint, it's actually when the user is climbing stairs, going up and going down. But do you know which one is the top one?
That one?
So is this going, it's when the user is climbing?
Yeah.
And this one is when the user is climbing down, going down the stairs. Well, to be honest, I don't know that myself either. But apparently there's enough information in the signal for a computer to accurately detect which one is which. So yeah, in this case is when the user is going up, you're right. And this one when the user carrying the phone is climbing down the stairs. Okay, but the final quiz, the last one, and I promise it's the last quiz. Do you know which activity this one is? It's a bit more complex.
Hang gliding?
No.
Bungee jumping?
What if I add an extra signal? This would be the heading of the user. You can see it starting from, you can detect this with the magnetometer, and it's the orientation of the user, starting from 150 degrees, then rotating to 250, and then coming back.
Is it driving?
No. It's actually the activity of going into a room when rotating around the door when the user is. So you can see you can get more clarity by adding additional signals. So not collecting just the accelerometer signal, but also looking at the heading and the orientation of the phone while the user is performing those activities. Okay, that's enough with the quiz. Now to get into the real business. Quick background about indoor localization or location altogether, so how it started. Even from the old days, people wanted to know their position. They wanted to know how to get back from hunting, for instance, or they wanted to know their position in the universe, so they started mapping the stars on the sky and how the Earth rotates around the stars. So we've always had the tendency to map our surroundings. So cartography started actually 1,500 years ago. We don't know if it's exactly when it started, but that's the oldest map we have nowadays. So it represents the city of Nippur in Babylon. And you can see here the river flowing or the walls of the city and some structures, physical structures on the map. So it's fair to say that it's safe to say that we've always had this tendency of localizing ourselves. But before the GPS era, how was navigation done outdoors? Starting with Navtec in 1985, and Fred here confirmed the information that I dig up, being one of the first employees of the company. They started digitally mapping the environment for navigating inside of a car. They were basing their information on gyroscope plus compass system that would estimate the orientation of the car, and also a way of measuring the distance that the car is traveling. And in that case, you would get corner by corner orientation in the city. For instance, if you wanted to travel from the airport to the hotel, you would get this information printed out at the airport, and they will give you indication of how to reach your destination. Imagine going into a new city and not having any other source of information. And another important aspect is they were also collecting some reference points, usually by image description. This means that they would add additional information, kind of like you have a coffee shop on your right or a shopping mall to your left, so you don't get lost. Occasionally you would want to reassure yourself that you're on the right track. This is an important concept because I'm going to come back to it later when I talk about indoor localization. But nowadays, mapping it's easy with Google Maps. They have a simple interface, and they also provide location based on Wi-Fi fingerprinting. Though it's safe to say that it's not very accurate. It has a range of around 40 meters. This is actually the informatic for the building that we are in right now. So you cannot actually tell where in the room you might be, in which of the room. With 40 meters, you can be anywhere in the building. So imagine the scenario where you want to navigate through the aisles of a store, a supermarket. You want to find sugar or aisle 5, for instance. Sorry. Using Google Maps, that's currently not possible. Or the same situation could be with finding a book on the shelves in a library. So what solutions do we have to get past to get even greater accuracy for localization? We have two current solutions, pedestrian dead reckoning and Wi-Fi fingerprinting. Very short way to describe what they both mean. So pedestrian dead reckoning, you start from a known location, and with a way of estimating the heading, the direction of movement of the user. This could be either from the compass, because it's accurately grounded in the Earth reference frame, and also assisted with the gyroscope. You can accurately get this estimation. And also finding a way to estimate the distance that the user is traveling. If you remember, the activity of user walking represents kind of like a sinusoidal signal. So you could easily impose a function on that, so count how many times the signal go past 0, and that will represent each time a user is performing a step. And having access to these two estimations, you can estimate the consecutive position and perform the same inference. You would have continuous estimation of the location. So if it's that simple, you would just start easily from this point, travel in a straight line, and end up at the corner. reality, it's not that simple. This is what you usually get in practice. And that is because you have additional interferences in the environment. In this case, you see a high radiation, which is caused by a magnetic door in this position. This has the effect of deviating the compass, and even if you combine it with the gyroscope, so fusing the two sensors together, the gyroscope is reliable on short periods of time, but it also accumulates error. The sampling is not always perfect, and you can think of the gyroscope as being a similar process with the reckoning. You build on top of previous estimations. And once you introduce small errors, those tend to build up and your estimation goes way off from the right trajectory. Okay, so what would be the solutions in this case? Relying on, as we were mentioning earlier, you can detect the user's activity. So knowing where the position of the elevators are and the stairs, you can use those reference points to recalibrate the user's position. So determining when the user is performing particular activities that are accurately localizable on the map, you can recalibrate the user's position occasionally. And also relying on Wi-Fi fingerprinting. A very short description of what this means is when you have your phone scanning the Wi-Fi environment, it can determine the access point that you see around you and the signal strength that they're received by the phone. And you can imagine we're collecting a lot of measurements from exhaustively in this case. You would just go cell by cell and get the exact measurements of all those positions, and thus creating a database of Wi-Fi fingerprint location pairs. And at runtime, you would just compare your current observations with the database, thus finding out the location where the user might be. I'm getting very much into technical details here, but I'm going to leave this description. If you're interested, you can find it in the paper. You can find everything is available on my website, open access. But a very quick description of what it does. I'm combining all the sensors with activity recognition and knowledge of where those landmarks are in the building, as well as Wi-Fi fingerprinting combined with particle filters to get a single estimation, which is more reliable than those.
Has everybody got a seat? Enough seats there? A few stragglers at the good evening everyone, welcome to the February Scottish Blockchain Meetup. It's good to see a full turnout again from everybody. So I'd just like to thank Portbase for hosting us this evening. And we've also got, we're live streaming on YouTube, so everyone on best behaviour. Thanks to Product Forge for doing that for us at the back. And also, well, tonight, I think hopefully everyone agrees we've got a good lineup. We'll start you off with, we've got a lot of different varied levels of blockchain knowledge, so with the feedback we've been getting, a lot of people are keen to see kind of blockchain 101, the basics and understanding. I know we've got a lot of experts here as well, so hopefully it's not too boring for you guys. But I'd like to welcome the first speaker tonight, so Greg Powell from Strathclyde University. Greg is a mobile and cyber security and blockchain specialist, so I'll hand you over to him for Blockchain 101. Thank you.
Thank you. Else we turn it on. So that's me, cybersecurity research engineer, that's the job title apparently. I work in digital security, cryptography, decentralized systems, mobile security, blockchain, etc. You get the idea. All these kinds of things. It's interesting stuff. Let me see, sorry, just going to quickly check my notes. Yeah, all these kinds of things. I don't know, I like to do other stuff as well. But I'm going to talk today about blockchain and give you a quick introduction to Blockchain 101. And I always like to start with a myth or a hype. You know, hype and myth, same thing. So there's a myth that Bitcoin invented blockchain. It's quite a prevalent one, it's quite a pervasive one, but actually it's not true. The first blockchain actually came about in 2005. Bitcoin was 2009. It was hash chains that we use to verify software source code. If you're a developer, it's called Git. Git uses a blockchain internally. You'll just not see it really. That's what the hashes are in your commits. And the second myth is that Bitcoins are untraceable because, you know, they're this evil cryptographic currency that is completely untraceable and you can do all sorts of, you know, disgusting and unspeakable things with it. So it makes a really good headline, but the fact of the matter is, it's pretty easy to trace. So it's me just tracing some Bitcoins. I think those numbers are actually measured in thousands. So 17,000 means 17 million. That's just tracing large amounts of money around Bitcoin. It's traceable. It doesn't tell you who it was, but we can come back later once we know who an address is owned by, you know, because they've had their house searched, and you can find out exactly what they've been up to. And you can never delete the records because, hey, Bitcoin is completely irreversible. So every transaction is visible forever. That's a big important property of Bitcoin. And it's one to keep in mind, but it's also a fundamental principle of blockchain. So all the funds can be traced to their creation, and we'll talk more about what the actual properties of blockchain are. But this is just something to keep in mind. It doesn't directly help you identify who's involved, but once you figure them out, you know exactly what they've done. So what is blockchain? Obviously we've got a lot of people here who know what blockchain is, hopefully, but there's also a few people who don't. So let's have a quick look. Fundamentally, yeah, not a joke, it's a chain of blocks. It sounds simple, but let's just see. So there's no maths. I did say in the introduction thing on the website there would be no maths. I stand by the promise. There will be no maths. First thing we need to know about cryptographic hashes. Again, no maths. It's a number and it represents a fingerprint of the data. It's like a one-way function. So if you get something that's easy to do one way, but difficult to do the other way, then that's pretty good. So for example, if I ask you to multiply two numbers, that's pretty easy to do. But if I give you a big number and ask you what two numbers are multiplied to get to it, you're going to have some trouble doing that. It's really quite difficult to go the other way. And that's a one-way function. You can't reverse it to find the input. A tiny change to the input is also going to completely change the output. Let's take a look. So here's an example. I've got a message. I've got a hash. Don't worry what the hash is, it's just random data. That's fine. I'm going to change the message really slightly, just a little tiny bit, and the hash changes completely. So now what I'm going to do is change the name. And again, it changes completely, because we've now got a different hash, because every message has a different hash. But if I give you a hash, does anyone want to guess what that says? What's the input to that hash? Come on, I've showed you three. Anyone want to take a guess? Well, it's not. Because actually, it's blockchain meetup Edinburgh. Point is, you can't go backwards. If I give you this, it's very difficult to go backwards. It's a computationally difficult problem to actually go backwards. And that's useful, because that means we can burst. We're going to have more than one thing to do. We're going to have more than one message to convey. So here's a message. So Alice bought item X from Bob for £10. All we're going to do is we're going to put the hash of the previous block in at the bottom of this block. And we get the hash of this transaction. Here it is. Now we're going to take the next thing that's going to happen. This is going to be the next one. So David has agreed a contract with Charlie for something else. And we're going to put the previous block's hash in at the bottom of it here. That's the same as that. We're putting in the hash of the last block into the next block. By doing this, we can start to form a chain. So let's just think what's actually inside that block. That's a really simple example there. But in a block, in Bitcoin, we have one or more transactions. In a more general sense, it's a group of events or records. So when you've got more than one thing happening, you can use that. A record of events, just anything we want to put in the chain. If you get something you want to put in the blockchain, that's your event in your record. So let's build a tree. Here's a tree. I built one earlier. So what we've got here is each block is linked to the next, because each block contains the hash of the previous block. And what that means is, if we verify the block at the top with its hash, that contains the hash of this block. But this block contains the hash of this block. And we all agreed earlier that we can't easily just change the input to a hash and get something different out. That actually lets us verify everything that comes before it. So if we store just that, we can verify the entire history. So just the hash of the top block is all we need to be able to verify everything that happened before it. And you can publish that, you can write it in a newspaper, you can put it on the internet as much as you want, you can tell everyone it, you can put it on a banner and hang it off Edinburgh Castle if you want. People can verify it and be sure that what they're seeing is exactly what everyone else sees. So if we had a distributed public ledger, it's a ledger that everyone can participate in, that's all over the place, there's no one spot that it resides in. Everybody can see the transactions and the operations that have taken place, but they can also now verify it. So when you make a transaction and put something and you want something put into a block in Bitcoin, let's take a look at what happens. First thing is you transmit that to the internet through your local networks. It goes through your network to the internet, and once it gets to the internet, magic happens, and it heads along the pipes to the other computers, the other networks that are on the internet, and once it gets there, it heads off to some other computers that participate in the Bitcoin network. And once it's here, they all can see your transaction. Your transaction has now reached all the other participants of the network, and that's really important, because what it means is they can all see what's happened, and that means there's no privacy in what's happened on Bitcoin. Everyone has to be able to see it for it to be valid. So let's talk about Bitcoin, a case study. It sounds boring, I just wrote that to make it sound boring. Actually it's not, okay? So this is what we think when we see Bitcoins. Nah, there are actually no coins, not even digital coins. There is no concept of a coin in Bitcoin. Bitcoin is all about bank transfers. There's no bank, but you get the idea. So when you transfer money in Bitcoin, you're actually not taking a coin and moving it around. You're just taking an amount of funds and transferring it to another person. So there are no coins, just keep it in mind. People think that Bitcoin works by making the transaction like this. So you take an amount here from this and you pay it here, an amount here and you pay it from this. But they don't think about what happens before it. You know, the idea here is that Bob has 1 Bitcoin, he pays 0.3 over there to Alice, and he pays 0.7 back to himself.
And traditionally, this is done using the GPS on the phone. But as we found out, this is not always very reliable. The mark zone represents indoors, whereas the white represents outdoor. So you can have a situation where the signal from the GPS is received inside of a building, whereas outdoors, when you're in areas with very tall buildings called the urban canyons, you won't receive a good signal, and that's how the system can get confused. It's not very accurate, and at the same time, it's a very energy expensive sensor. You probably know if you let them just on Google Maps, drain your battery very, very fast. What about reliability? New labels for the system, which means that you can have the system continuously training itself. And our performance was in the 90% accuracy, surpassing all the other systems before us. Cool. And the last context that I'm going to talk about is activity recognition, but this time using a different architecture. This is based on deep learning, and we're using 2 modalities in parallel, in this case accelerometer and gyroscope. With deep neural network on each of the modalities, you would extract preliminary features, which can then be combined to come up with a single estimation. So our observation is that pre-selecting those features by the network independently on each of the sensing modalities is more efficient than just putting the data all together into a single architecture. That is because one of the sensors may dominate the other, and you miss out important information from each of the sensors if you don't allow it enough space to extract its own features.
Valentine, a couple more minutes.
Okay, yes,
Yeah.
I'm getting close.
Okay, good.
Just very fast, the evaluation for this system. We had the larger data set, 9 participants, each of them were performing 6 activities with 8 devices, and we surpassed the previous classifiers. Ours was in the 80%. You may say this is very low, but actually the training was done with a method of leaving one of the participants out and training on the rest. So this resembles kind of like a fresh system for the other user. Imagine you're developing an application and you want to release it and be used by a lot of users. So you don't have label data from all the other users. But the observation is that if you specialize the network on the users later on, you can reach 95 to 97% accuracy on those users with less than 5 minutes of additional training data. Okay, the energy efficiency we evaluated with the development board, the Snapdragon, the processor very similar to the one you have in smartwatches and the older generation of smartphones, just to have full control over the measurements. And what we found was the impact of energy consumption on a battery, on a typical battery on a smartphone is less than 1.2% of the whole battery for this sort of inferences and sensor sampling, just because the sensors are much cheaper than the GPS and all the other sensors. Okay, so getting close to conclusions. Why is this important? We have a debate nowadays that moving our data into the cloud and helping our services is beneficial to us. But with such a system, you have everything under control. You produce the data locally, and you also consume it locally with specialized context detection algorithms. In this case, you don't need to transfer a large volume of data to the cloud. So you have nowadays the problem with Amazon Alexas. The police is trying to get access to their to voice data from one of their users in California because of a crime scenario. So you can actually see how harmful it can be to send your personal data to the cloud. But performing all the inferences locally avoids all these problems while still taking advantage of useful inferences to assist you throughout the day. Okay, so the vision is that many inferences will be performed locally on mobile devices and wearable. So we'll have more and more of such inferences happening on our devices. The default setting should be off for uploading the data. Everything should happen locally to the device. If you want to improve the algorithms and the architecture, the deep neural network architecture, then you'll have to give some incentive to the users to upload their data. That can be cash or discounts next time you're selling them something. Think of bus companies, they'll give you a discount next time you're purchasing a bus ticket. Finally, you're not going home. Arrangements to prepare or signal your house to put on romantic music and turn on the lights. At the same time, you can also instruct your personal robot to start cooking your favorite meal to be ready once you arrive at home. So I'm going to leave you with this question. What interesting and useful context detection can we think of to improve our life? Something that can happen on the phone with the sensors we have available for that. Thank you. Oh, sorry, before that, I need to acknowledge my collaborators, my supervisor Mahesh Marina, Lito, Yota, Rick, Nick, Surav, and Cecilia. That's it.
Great, round of applause. So, this is actually the power, okay, of the network and the community of action. I had a friend who's an entrepreneur. What do you call those things when you go, you're like groups of teams and you go on a hunt to look for things and you get given sort of scavenger hunt. Or treasure hunt, exactly. And he said, I want to do a treasure hunt with mobile phones. So it's not the most original idea, but his question was, how on earth do you do very targeted and localized indoor GPS? I don't know, Google it. Now, how many times have you been coming to the IoT meetups and how long have we known each other? I had no idea that's what you did. You are literally a domain expert in that field, right? So if there's someone who knows about indoor GPS for this particular idea or any application, you're the go-to guy. So that is the power of the network. It's just spreading that information and getting referrals and
there's a company in Glasgow that's got a Wi-Fi map of all the Wi-Fi stations in the world, you know it?
They're not the company, but there are a few.
Yeah, no, this is a company that does it. And they put an app out that allows you to track local Wi-Fis. But they suck all the data back, and they've got a map of all the Wi-Fis in the world.
So before we go to our next speaker, the other comment is, for me it's quite difficult to know exactly how to pitch the level of technicality. And there are times at which I can see half the room literally kind of going, oh god. When they see something too technical, and then the other side of the room light up, lean in, oh my god, technical, brilliant. And I think what I'll try to do is mix it up, maybe have one slightly more technical, one more strategic, one sort of like make it more kind of practical, just to try to keep everyone happy. But it's impossible really to know how technical to go, and I think you struck a really good balance because I was able to follow it, and in itself that's quite a challenge. And I also think that there are a lot of highly technical, very niche meetups out there that cater quite well for that, like Tech Meetup, for example, that's at Skyscanner each month, isn't it? And then there's probably the Python, the C++, and the Java meetup groups. So I think, like I said, they're very highly technical, very well catered for, which is why I tend to prefer to just steer clear of getting too deeply technical or start going through lines of code and so on. So I thought your talk was excellent and it was a really interesting balance. So well done. Thank you so much. Right, let's have a little brief break. Guys, go and grab a drink and a snack. We're just going to configure and set up for the next speaker. Literally just 2 minutes, just 2 minutes. Just keep the momentum going because we've got a third speaker. Right. So, sorry. So, we've got Sergio Senna, who's going to talk about unicorn seals. Is that a unicorn seal? Is it seal? What's that? Oh, I thought it was a horn. Come out, mate. Have a seat. Grab a beer. All right. Oh, good with the live stream, Alan. Find out the technical glitches. Come on, Patrick. Okay. Right. Right. So our next speaker is, as I mentioned, is Sergio Senna. Now you've come all the way from St Andrews, is that right?
Yep.
And you had a little bit of a nightmare getting here, is that right?
That's true.
Perhaps you can start by explaining what
Yeah,
a hero you were to make it all the way down from St Andrews. Let's have a round of applause.
Thank you. So I've spent, before showing you the presentation, I've spent the last 3 days up north in the farthest point of Scotland, in Thurso, on a field trip, checking the new sites for our base stations. I'll show you some pictures, and I have a video. I don't know if we have audio. The audio will just give you wind, because that's how bad the conditions were up there. So, so who am I? I've been electronics designer for 15 plus years. I've done many things between digital processors, analog power, and since I started working with sensors, radio, and trying to put things on the internet, going back from 2009, I've always tried to do everything very low power. At the time, maybe before a bit before that, people weren't much interested in going low power because we have big batteries, but now everything is portable. Everyone wants the batteries to last 10 years, and that got interested in that. So past lives, I built robot vacuum cleaners, smart meters, and I was also a lecturer, done many things. For those that are radio operators, I am Charlie Tango 2 Golf Papa Whiskey. We can talk at the end about it. So, I've come from University of St Andrews. There's a research unit called CMAMO Research Unit. And so, who is and what does the CMAMO Research Unit do? So, it was established in '78 by NERC, the Natural Environment Research Council, and the SMRU has 40 people between academics, researchers, and student staff, and mainly it's marine biology research. Was in Cambridge, 96 moved to St Andrews. It's part of the Scottish Oceans Institute, that is part of the University of St Andrews. It's an independent research group, so part of NERC, and supplies advice to the UK government on all things marine. Okay, so yeah, last year, late 2015, early 2016, we established a partnership, a strategic partnership with Vodafone UK for the M2M. And you will understand why M2M, machine to machine, after I show you what we do at the instrumentation group. So the instrumentation group is a group of 10 people. We have 30 years experience designing electronics. We design, build, test, and commission tags. You've seen that seal, that picture of the seal with an antenna on the head. I will show you what that is. So we design hardware, firmware, software, mechanical, we do the assembly, encapsulation, potting, and we do the field test. So from the initial idea until we send the tags to the researchers to the field, that will go everywhere on Earth and seas, we do it. We're not the only ones, but we are very well positioned when we are working in a niche environment, and we are top of the group. As I said, tags work on all continents and sea. We are proud of that, and we can corroborate this. Our tags withstand from -25 to 40 degrees. Remember, if they work on the tropics, we're talking about 40. If they work in the poles, when the animals are out of the water, we have to withstand at least -25 degrees. 200 bar, and that's 2,000 meters depth. The tags have to withstand that pressure because some of the animals, some seals, some whales go at to that depth. And of course, between 3 to 12 months operation, some of the tags sometimes work on a multi-year, special for turtles if we have solar charging on our tags. And between 3 to 12 months, and it depends on how many points per day or per week or per month do you want, if you want acceleration data, if you want GPS data. So the more points, the more information you want, the less battery will have, because you have to transmit more power or you have to log more times, more frequently. Okay, so what kind of technology do we use? We use extremely low power digital and analog electronics. Everything is designed by us in-house. For transmitting the data, we use GSM GPRS. We use Argos satellite. I'm sorry, can you see this? Yes. Yeah, back there? Okay, thank you. We use Argos satellite. Argos satellite is a network of, if I'm not mistaken, 6 or 7 birds flying above the Earth in 401 megahertz. You have Argos 2, that is only a beacon, only for transmission, and you have Argos 3, that you have a transmission, and you have between 1 to 3 seconds a reception, like a mailbox. So we work with both. We have UHF proprietary, and now we are using LoRa, and I mean LoRa and not LoRa 1. Okay, that's a big difference. And we are prototyping already. We narrowband IoT, and we've been sponsored with on this by Vodafone, and we are prototyping also with Iridium, so we can have. Oops, I'm sorry. We have a bigger bandwidth than Argos, because with Argos satellite we can transmit 32 bytes every 3 minutes, and most of the time the satellite doesn't see it because it has only a 10% efficiency. So we are talking about 6 or 7 birds flowing, and you have to be really lucky that your transmission gets to that satellite. So 10% efficiency. But very low power though. It's very, very low power. Iridium, it's high power, high bandwidth, so there's a trade-off. Depends on the work you want to do. Some work you can withstand the power, other work you cannot, so it depends. We have solar energy and battery charging with very low power solar cells and very low power circuitry. We use fast lock geolocation, and fast lock, it's not a GPS. GPS, as you know it takes some time to grab a position, a few seconds, sometimes 30 seconds, 1 minute, and that is a lot of power. It's always in constant grabbing. Fast lock reads the sky for 50 milliseconds and then post-process all data for 12, 15 seconds, and gives you how many satellites are there in the sky, and gives you the strength of each satellite. Then you transmit that to the server, and then on the server we calculate where the animal was. So instead of spending several seconds with a lot of power being wasted, because for us it's wasted, we spend 50 milliseconds of high power receiving the radio, and then post-processing with DSP and FPGA on board all the data. Also, we have conductivity, temperature, and depth measurements. and high precision, definition, and repeatability. We have also fluorometry and tags, high precision light meters, down to the number of electrons. Yes, we can calculate the number of electrons. At 2 kilometers depth, the number of electrons can be counted. And for that, we use a kind of light sensor built from a Japanese company, Hamamatsu. It's the best light sensors that are on the market, and we calibrate them in-house. And we can give you the number of electrons on that time frame. Some researchers want that because at 2 kilometers depth you don't have any light for us, but some animals can detect the photons. Other sensors that aren't here are accelerometers, gyroscopes, and magnetometers. We use all that too. Okay, so what you see here, it's an old generation tag built with an 8-bit processor, still an old design from the 80s. These tags, we're still shipping them and selling them until we finish our new generation. With this processor, I think it was an Hitachi Renesas processor, we can't do much in terms of sleeping. If you want to do something, the CPU has to be awakened. That means power wastage, and even for a small job as counting timers, everything needs to be awake. That's a very power wastage. So in a sleep mode, we waste around 10 microamps. You say 10 microamps is nothing, but for us, we can fly to the moon with 10 microamps. It's a lot of power. Because remember that these tags need to be asleep all the time. Once in a while, seconds or minutes, tag wakes up for a real-time clock, or for a transmission, or for a sensor grabbing. So the average needs to be much lower than this. And the leakage of these circuits, since this is an old circuitry, the leakage is very, very high in terms of the components used, because they are all components, too much capacity on the board, so there's a lot of leakage. New generation. I will show you later, the next slide, a comparison between both tags, so you can see the differences. We're using now a 32-bit ARM Cortex M4 with DSP instructions. So most of the things that we were using, the older tags that took seconds to do, now we do it in a fraction of a second. The good thing about this new technology is that all the peripherals inside the CPU, the processor, can work while the CPU is sleeping, so everyone can exchange data, work, stop, start, stop, start, stop, exchange data, and the CPU is asleep and is stopped. And that means great power savings, because if the CPU is stopped, there is no extra power wastage. We have an average between 20 to 50 nanoamp sleeping if we shut down everything on the board. And our main consumption is below 1 microamp, including the leakages and everything. But we need to shut down everything on the board except the processor running a real-time clock. Okay, so you see the differences between the old and the new. It's more than twice the reduction in size. There is always a trade-off between the size of the battery and, of course, the longevity of your tag. If you want a tag to last between 9 to 12 months, there is no choice, you have to choose a larger battery. If you want a tag that will give you information for between 1 to 3 months, you can go on a very short, very smaller battery, but still you don't have the longevity. So it's always a trade-off. Looking at the technology inside, that's the old board, that's the new board. If we rotate this board 90 degrees clockwise, it's more or less 3 times 1/3 of the size, I'm sorry. And there's still a lot of space there. And you can also change the design. There's a GSM, GPRS modems and many connectors for other sensors.
Roughly how big is that, just in terms of scale?
Yeah, I should have put a coin there. We're talking about 3 centimeters by 6 centimeters. Okay, it's still small but large. For some animals, it's still large because if you add the battery, there's a bigger size there. But trade-offs. Okay, so in terms of IoT, Internet of Things, we start developing with LoRa in late 2015. We've done our first field tests in February 2016, that was a year ago, and the first tests were very successful. We went to the market and grabbed the modules that were available, connected to our tags, built the base station, put the antennas on the roof, we done all that. So we got 99% packet delivery over 12 kilometers and near line of sight. And when I mean near line of sight is that the receiving station was blocked by tall buildings, and that was it. After those tall buildings, there is a big, I don't know if you know St. Andrews, it's called West Sands. It's a very large bay, really shallow. There's nothing in between. So with the power that the module gave us, 14 dBm or 35 milliwatts, we got a 90% packet delivery, and it was, we confirmed it because we always put the tags on the sun. That's our test, because the animals, when they haul out on the beach, they are always on the sun. They are not standing like us, they are lying down, so we had to put everything on the sun and do the testings. We tested several antennas, PCB patches, PCB copper ducts or vertical antennas, small, and even with that antenna, and that is 1 centimeter by 2 centimeters, we got 99% packet delivery. And we're talking an antenna that it's a negative gain. Okay. The base station has a very good antenna, plus 11 dBi. Okay, and it's the building, the roof of the building is at around 20 meters above the sea level. It's not optimum, especially because you can see here the roof. The antenna is really close to the roof. The roof is metallic, so there's still a bit of a loss. And these were the tests 1 year ago. That's me holding the everything with wires, and it was working. So after these first tests, we went on and built a real system. So that's St. Andrews here. Our institute is here on the beach, and we went to Tensmute Beach at the time, and we got around 12 kilometers near line of sight from one point to the other. Okay, so what's being done now? We have beta testings since last year, and we will have another group of beta testings in April 2017. I've been up north, as I told you, checking the sites for the new base stations. There's a new tag design being launched and being put on the seals. It has been designed centered just on LoRa. Okay, so we decided that we wanted to use LoRa for our UHF tags, and I designed the tag around that concept. And this is all to prove that the base station is up to the task, that the tags are up to the task, and so we can release version number 1. It's still everything in beta, but it's still working. So new tag, some of you probably, if you follow me on Twitter or on Facebook, have already seen this photo. This is the same size, 3 centimeters by 6 centimeters, as our ARM Cortex. With DSP instructions, 1 gigabit flash memory to log all the information from GPS and sensors if it cannot talk with the base station. Okay, some animals spend a few days at sea away from the base station, so they need to save all data. That data is really important to the researchers. Our LoRa radio, we chose a module on the market for this attempt to test of the LoRa system. Revision number 1 will have the chips, the radio chips, and not the module for convenience. It also has a fast lock geographer kind of GPS. It has also a conductivity, temperature, and depth sensor with an extra depth sensor. Wet-dry sensors are sensors that detect when the animal is in and out of the water. So it's important that we transmit only when the animal is out of the water. And this has a lot of power conditioning circuitry and also circuitry to disconnect everything that is not needed on the board. So when the animal goes into the water, we can disconnect all the radios, all the sensors that are wasting power. So everything is off. And there's also a magnetic switch because everything will be encapsulated in epoxy. There are no electrical connections, no buttons, nothing. So using a magnet, we give controls to the tag, switch on, switch off, combinations of switches, of magnets. We can do some programming. So that's one of the ways we found that works. So that's the base station where it is now, operating in East Sands in St. Andrews. It's been there since February last year, working well. That's part of the PCB inside for the people that like to see it. So it's also an ARM Cortex M4, has SD card for logging all the tags that connect with it. The LoRa radio is the same radio that's on the tags, so full compatibility. It has GSM and GPRS to talk with our servers directly, so when there are enough tags, when enough tags have talked to the base station, when we have an amount of data, there's a connection by GPRS, FTP, or HTTP post to our servers, download data. Also power conditioning and power switches for everything on the board. It has mains power. It can be powered by mains, it can be powered by solar panel, it can be powered by battery, and the solar panel and the mains charge the batteries. It has USB connections for a console outside or for downloading data. There's a user interface with LCD buttons for if the researcher goes on the field, opens the box, presses the button, see what's going on, you can see traffic, you can see all the tags that are talking. You can take the SD card, substitute the SD card, or just press the button and send all the information that it's still on the SD card back to the server. Future development for revision to add Ethernet, Iridium, and make it portable. It's already mobile. It's not portable, it's mobile because you have tripods. That's not much portable because it's still weight. So these photos were taken 2 days ago, so you can see where we use our stuff. That's first generation base station. That's one of my colleagues. And that's their top northwest point 2 days ago, before the storm So today is the 23rd. Yesterday, 22nd, we went back to the sites again, and we couldn't walk. Twice we had to lie down on the floor because the wind was so strong that, yeah. Any questions?
So we'll keep the Q&A brief. I know Rob always has questions because we're going to do the panel Q&A at the end. So just make it quick and then we'll do the kind of open Q&A thing.
Have you investigated over time the idea of taking physical energy recovery devices on the tag, barometric energy recovery or flow energy recovery systems?
Yeah. We've tried in the past using the flow. Barometric is not. We could use barometric. We've tried piezo sensors, and not successful because of the force that the animals do when they move. It's not enough for the piezo to work. We've tried flow, but still it's big. Still to give proper energy to charge the batteries, or at least for the transmission every hour. It's not enough. So it's still too big for the tire, and that adds weight and drag. And that's a lot of drag. And the animals don't like drag, just like us. If we have a big backpack, we can feel the weight. For them is the same. For us, it looks small for us, but for them, it's not good.
That was almost my question, just that you could use like a mechanism from a mechanical watch, a self-winding watch, to try and wind up a spring or something that could boost the battery and give a little bit of energy. Because the animals obviously are moving around, the seals are moving a lot.
Yeah.
So, a self-winding watch, you don't have to move a lot to wind it, just maybe not enough time.
That's a good idea. Maybe the wattage is not enough. Maybe for sleeping, maybe for fluctuation currents and for leakage, maybe for that. But for that we have a solar cell already. Every time we'll have a solar cell just to counteract the leakage and the sleeping currents, mainly for that.
Yeah. You mentioned Vodafone and their narrowband IoT network. What's your experience or your opinion on that?
I can't give you any feedback yet, because we just started. Okay, the narrowband is not illuminated in the UK. You have to go to Reading, to their offices. They have a lab there if you want to test it. So until the illumination in the end of 2017, early 2018, I can't give you any feedback. It works, it's good, it's comparable to LoRa, but different business model. I can say that they work really the same, but with a different business model. As LoRa it's private, it's everyone working for everyone, and the IOT it's yes, it's like
how many tags do you think, in terms of the ratio of tags to base stations, how many tags do you think you could scale up, you could get to moving up, and what are your strategies for keeping track of large amounts of tags at scale?
That's a good question. We don't use LoRa on purpose, okay, and the reason is that LoRa has an overhead of energy and data transmission that we don't need, and by that we can use the ISM frequency band more often to transmit more or less data. How many devices or how many individuals we can have on the network, we still don't know because we're still scaling this, but we know that we will not have more than 100, maybe 200 individuals. And even if we scatter base stations on the same geographical location, as before, every base station has a random acknowledgement time. So when all the base stations, if all the base stations hear that tag, they will have a random acknowledgement time. That means they will not reply at the same time. There's always the first to reply, and then after milliseconds, the others reply. So I reckon that between 100 and 200 we are safe. After that, it starts to get...
Guys, I think we're going to wind it up there. We'll return to Q&A later.
Oh, finally.
We just
finally
need
let's
to move on to the next speaker who's on stand.
Thank you. Thank you.
Okay, Sergio, thank you so much. This is Colin from Decent Relation from Sky Futures. These guys use drones to do very cool things with drones, and anyone who knows me knows that I like drones a lot. I'm quite excited about it. We've got some increasingly impressive clients here in the United States, and use drones for, I think, mostly asset inspection, so structural health monitoring. But increasingly, drones are going to, I suppose, the next generation is going to be completely autonomous. So, we shall see. Now. I'm not getting any sound. Hold on, I don't know if you can hear me, but I'm just going to call you now. I can't, I'm not getting any audio. Hey. So, okay, but I'm not getting any video you're in. Okay. Yep. But I can't hear you though. I've got no audio. Okay, yeah, we're just putting the mic on you. Yeah, sure. Go for it. All right. Like last time, you scribbled it around. Still there. I'll end you there. I thought you should. Guys, do you want to chat amongst yourselves as you get another drink? This might take a while. Sorry for those on the live feed.
you say? What would you stand for president?
Yeah, I'm talking now. Can you hear me from the computer? Yeah. Great, I'll hang up my phone.
Alright, go there.
You see my screen okay, son?
Right, so,
Are you guys okay?
there you go. Round of applause, take your seats, grab a drink. Okay, you're on.
Right. Hi everyone, thanks for suffering the remote presentation. I know they're not always the most pleasant. I've been watching the talks so far, very interesting. I'm going to come at it from a slightly different angle, so I'm going to come at it from the business side first. And you know, we at Sky Futures, which is kind of a drone-based inspection company, we use drone technology and also a bunch of image analysis and cloud technology to solve problems for our clients. But the story I want to tell is kind of working back from the market that we went into to try and solve some of the inefficiencies. And then I'll give you a little demonstration of the product that we built that kind of is like an end-to-end solution. Once you've kind of flown a drone and done some work, I'll show you what you can do with that data. It's really interesting. So, you can see in the presentation, I've got the old way of doing things, right? Not to pick on the oil and gas business, right? I mean, you know, politically, you know, no comment, but they do some fairly remarkable things in how they provide energy to us. You know, there's a lot of incumbent investment there, and it's not going to last forever, but fast. I'll give you a kind of walk of how things work, right? So this is an oil company, and a lot of equipment around the world that needs to be checked to make sure that it's running. Because when it's not running, that costs a lot more. Right, so somewhere in this business, there's an inspector team, and at some time early in the year, plan. They know by law in the UK, they have.
Okay, Sky Packet. Right, well, we might have to go old tech, old school. Speakerphone next to the mic. I'll call him sec, because it's not going to work. Skype. Seriously, in this day and age? Come on. Just a sec. He's going to be really annoyed when I say, back up and repeat yourself, because we can't hear anything. Speakerphone. Okay, we got serious packet loss, can't hear a thing. I'm going to have to put you on speakerphone so you can speak through the mic. And hopefully your slides, yeah, you need to go back to your slides because you just got a full screen of the video camera. I think, is that the mic or is that the mic? Any idea? This one? Doesn't matter. Okay, now you need to mute your mic because you're getting echo. Let's see how this works.
I see. Yeah, I get it.
You with me?
Right, so, you see my slide? Can you hear me okay?
Hold on, no. Okay, hold on. Just a second. It's going to work, right?
Yeah, it might work.
Thank you. Old school. Right. Okay, you're good to go.
Excellent. All right. If you can hear me okay, this is a good demonstration.
Right, so this is kind of what goes on in business. You have to look at expensive, dangerous equipment. A team of people get together in January, make a plan, and then sometime later, a manager signs that plan off and says, yeah, right, and there's an annual inspection plan. It contains a lot of details, right, and it requires a lot of work. So months are passing by in a business, and you need to be coordinating rope access teams, non-destructive testing teams using things like ultrasound to test the depth of metal and things like that, specialist technology. Some scaffolding, vessels, helicopters, bed space, food. There are huge aspects to all these projects of getting people to go and look at stuff, basically. And that's just to work out what's gone wrong. That's not to actually do anything, it's just to look at it. And then you start preparing for the job, so you put things out to tender, you start getting equipment ready, all manner of admin tasks. People travel halfway around the world to get to jobs. And then on the job, it's very complicated, right? You can imagine that a bunch of people climbing around a ship that's up in dock, or an oil platform, or whatever it is, a wind turbine, a telecom mast, a bridge, things like that. These things take a lot of time and a lot of effort. Typically, in oil and gas, if you shut down a site, that's costing you about $7 million a day, and you're putting 4 people on site for 8 weeks, or you can reverse those numbers obviously to cut the time down. So you've also got risk exposure, because these people are in dangerous places, doing dangerous things that, if possible, we'd like to avoid. So this is a huge business opportunity for technology, right? And then the output, unfortunately, as you can see in the top left-hand corner, is the result of this poor guy hanging on a rope, trying to get a first-hand look at this stuff. That little bit of pipe work that he's kind of near there, the little kind of elbow bit, that should be a platform that he can stand on, but it's washed away in the sea, right? So he's like dangling down on the rope, trying to get a look at it to see what kind of condition it's in. So these reports are kind of subjective. They're not, they're written by a person who's working in pretty, they're not actually writing them at the time, but they're taking notes. They're taking those notes back. So it's kind of somewhat first-hand information, but not really. It's not this, and it's hard. So when that data comes back to the company, I think I just did a couple of clicks accidentally there. When the report comes back to the company, it's usually taken quite some time, some weeks to get that data together, and it comes back to the business. Somebody in the business gets that report and they start to create some kind of follow-up action. So it's 8 years passed pretty much. That's what's involved here. And somebody then signs off and says, yeah, those things are all broken, let's start looking at fixing them next year. And then amazingly in parallel, lots of other people in the business are all actually doing similar activities for different reasons. And this is just how it is, that old adage of they're constantly painting the Golden Gate Bridge. When you finish painting at one end, you start again at the other end. That's kind of the nature of this business, it's high and laborious. So drones are great. We all know what drones do, little helicopters with batteries and computer brains. We haven't used petrol helicopters in the past for doing this kind of work because, there's been hobbyists flying aeroplanes down at the park for years, but they've not really been used for any kind of application in business because of the limitations. When you've got flying robots, you can do a lot more. So this is what the drone industry does, and this is what the business and Sky Future is doing. Generally,
what the expectation is that the drone will fly every day. So you're constantly hoovering up data, visual inspection data. And this is interesting from a business perspective for those who are interested in drones, right? When you think about this from an Internet of Things perspective, the drone you can see in the picture there is, I think it's €50,000, something like that. And it's specialist at the moment, but that price will come down. And the guy in the picture there is a Sky Teachers employee who is brought out because you need to be a specialist person who knows what they're doing in order to fly a 50,000 quid drone safely around a major hazard facility. You need legal permits and insurance and all of that kind of stuff. But we all know with the Internet of Things, it doesn't work if people are doing the specialist work, right? It's like somebody buying a smart washing machine,
Colin, can you hear
and
me?
then somebody, I can, yeah?
Can you hear me? We're getting a little bit of distortion. Do you have like a Bluetooth headset, or can you speak a little bit less close to the mic? There's a little bit of distortion.
Yeah? No problem, yeah, is this better?
Yeah. Give that a go.
Okay.
Cheers.
So, the concept of this is that in the early days of this you can think of it as a technology solution fit, right? As this evolves into product market fit, what's going to happen is that person flying the drone will be a person who's already on the platform. So they're not a third party that's brought in, so that we can already see the end of our business approaching, right? And this is the truth for all drone inspection businesses. Ultimately, what we need to do is enable people to have these drones themselves, so we work it out and then we sell that methodology on to the businesses that actually have staff there full time. And that's the idea. So we're building a technology platform which, let's go back to the presentation. The idea is that you fly the drone lands, the data goes up to the cloud, and then this is what we present our customers with. So it's a portal where, I'll give you a demonstration of it now, where we take the data and do something clever with it, right? So I just switch to another tab here in this window. So this is the software that we offer. So the idea is that somebody goes onto an oil platform, they do a flight, they collect a bunch of imagery and video, and that's what people are collecting today, whether it's visible light or thermal imagery. And they upload it to a cloud platform. And here's an example of what a client would then do. So because it's in the cloud, anybody who works for that business anywhere in the world can log in and see the data soon after it's been captured by the drone. So I clicked on that blue dot, I'm loading a close-up view of that facility in that part of the world. And what's happening when the drone lands is that all of the image data that's coming in is all smart information. It's got the telemetry information off the drone, so we know the compass bearing, the GPS coordinates, things like that. That's not great at the moment, to be honest, as you guys know, because GPS location, as we saw earlier tonight, is not very accurate. It's tens of meters accuracy, which if you're trying to find a very important crack in a pipe, you need to know in detail to less than 10 meters, right? So there's other techniques that we have to bring in, using image analysis to try and use the GPS as a heuristic to get in the right ballpark, and then you use image analysis to find the thing in detail. So here we've got a very slow kind of 3D model of a platform loading. My machine says like it's line up at the moment, doing a lot. And all of the image information and video information off the drone is organized and put into a system for people to be able to get access to it easily. So here's that oil platform, and you can see there's some red things, so some problems have been spotted within the imagery. And when I click on the red dot, I'm taken to the cracked cap. And you can see in this image that, depending on what quality you're getting of a sky, there's detailed imagery of a crack in a weld-reinforced ring on what is actually a critical piece of equipment on this site, this offshore facility. But what else is important is this flare is still burning. So this is not possible without a drone. If you were standing there taking that picture, you'd be cooked. So it's pretty incredible. This is a drone flying at 20 meters from the object with really, really high power, which is pretty exciting. If I go to another example, just here, there's a problem with this pipe, and if I just load this video, you can see that it's really engaging. You can, from your desktop anywhere in the world, get to this important information showing these issues, then you can manage it. So flying drones is only really just, it's a quicker way of putting up a ladder unless you're doing something with that data. So it's really, it's the Internet of Things is really part of, it's the cloud processing and the image analysis technology that really empowers drones to be useful. Otherwise, you might as well just use a GoPro on a selfie stick. So I've scaled this image manually, and what I can do is using some seeds. We're at the stage of training classifiers here. I can mark up corrosion and then get a quantification edit. So you can pass back a version of the image which has the extent of the problem quantified. So if you piece that into the story where a drone in a box is taking off every day, systematically photographing the entire surface area, we stitch the entire thing together into an ortho mosaic, we pass every single image through we chop that back up into tiles, we pass every image into a corrosion identifier and quantifier, and when a drone takes off and lands every day, instead of producing just a media library, it's going to produce, it's just basically an update dashboard that says, here's the problems and this is how much worse they've got today, and therefore give you your priorities as to what you've got to fix. So it's a huge step forward for what is a very dangerous, expensive, invasive method of inspecting things manually. And drones are really, they're kind of saving lives and saving people hundreds of millions within our clients. It's really good fun work. And it's got lots of future potential as well with other problems that we can spot with thermal imagery. We can use hyperspectral cameras to look at kind of crystalline structures in metal and things like that to try and see problems before they even occur. But yeah, there you go. That's my 20-minute time.
Excellent. Thank you. Round of applause. This, in my view, is the very definition of boring be sexy. I cannot state how game-changing this is. You're looking at bits of oil rig and it's got corrosion on it. No, these are flying robots with machine vision and machine intelligence that are automating processes that currently take huge quantities of man-hours and putting human beings, in situations of high risk. People get killed doing this job. And if we can send, I don't like the word drone swarms because it's got very scary military connotations. And so let's call them flocks of drones. So they'll be buzzing around doing extraordinary things. And this kind of stuff is so sophisticated, but it's being applied to something which is essentially structural health monitoring, okay? But that translates into billions and billions and billions of dollars of value throughout many different heavy industries. So if you're a company operating in this market sector, obvious, payday waiting for you. There are big multi-gazillion dollar companies who need this product and service. So are you looking for investment? Sign me up, Colin. Okay, so we're going to move on quickly now, briefly to an audience Q&A. Do you guys want to come up to the front, just grab a seat, and we'll just do, and also let's open the discussion, because you know that I like it. So grab a seat. That's what I like to do. So Jake, going to come up? Colin, if you can hear me.
Yeah.
Maximize your face on the screen and join us. So ditch your slides. Maybe shift towards the microphone because you guys don't have a look on my right now, do you? So that the mic feed can pick up. That's better. All right. So sorry, I should be pointing this laser pointer line of people in the audience. Somebody had a question and I cut you off rudely. and it was to Sergio, I think. Was that you?
This is me.
What's your name again?
It was something to do with flow.
What's your name again?
Paul.
Paul, that's it. Are you one of the hack guys?
Yes, I was.
What? Oh, really? You've quit now?
I've quit now, yeah.
Okay, that's another story. Maybe another story another time. I just want to talk about it now.
I still
Okay, go ahead, sorry.
I can design stuff, you know what I mean?
Okay, you had a question.
Well, it was to do with the turbines, small turbines on the mammal. As it flows through the sea, it will generate electricity to power the batteries.
Yeah, that's a very good idea. Thank you for that. The only thing that is more important to us than energy for the electronic system is the energy that the animal has to sustain, has to waste to move. So we've been designing a new envelope for our tag in partnership with Plymouth University. We have a new envelope already. That's going to be on these tags in April, and adding something like that with the cable to the tag, it's an increase of a minimum double the energy consumption in the animal. So the animal.
So it's not good for animal welfare, is essentially what you're saying. Okay, that is an important question.
That's the
that's going to be my question actually. Have you had any issues with animal welfare? Or perhaps people don't even know you're attaching these weird horns onto seals and that the animal welfare people are going to get onto you when there's more awareness of this.
Yeah.
Is that an issue as far as you're concerned?
It's an issue, of course, and everything is regulated.
Okay.
Everything is very good. There are a number of licenses per year.
So you get spot checks from animal welfare associations? How does that work? You say that?
Yeah, they know the work we do.
Okay, so they're checking the weight, the size, the dimensions.
Yeah.
I see.
And also how the animals are captured, because they have to be captured. We need to put tags on.
Okay.
And most of them have to be tranquilized. Okay. Then they are glued to that.
And the purpose of what? The animals, ultimately you're doing this for the ecosystem. So ultimately you are doing this for the benefit of the animals, right? Yep. Or no? What is the point of this research?
It's the benefits of the animals, to study the animals, to study the ecosystem, to find answers to questions that you can only answer with this kind of topic.
So give us some examples of some breakthrough insights you've learned.
The wind generators off the coast of Scotland. There was no idea. First thought was that all the animals would swim away from the wind generator farms, big farms. But with this system, we got to know that they go there, swim around the coasts underwater. And
so they like it?
Because the
sorry, Karen.
The wind generator poles start to form biofouling, so all the fish go there.
So it's actually benefiting the ecosystem.
Absolutely.
I actually saw a documentary on the BBC about that very thing.
Yeah, most of the sea is in fact sterile. Well, not sterile, but there's not much there. As soon as you put something there, it attracts a whole series of different forms of life.
Exactly.
And that's what's happening.
Yeah.
Away from the shore, there isn't a great deal out there.
Well, they used to sink cars.
Yeah, people make artificial reefs to try and attract various people.
Yeah, so that episode of Grand Tour where they were chucking cars to try, literally disposing of car chassis and chucking them and creating these artificial reefs. It's amazing. And they came onto the metalwork and, sorry.
So, just a question. You're talking about LoRa. I don't know much about it. What frequency does that operate at?
You have, for Europe, for us in UK, you have 434 megahertz or 868 megahertz. And we are using 868. Smaller antennas, better penetration.
Thank you.
Actually.
Okay, well, just a quick one to start. Blue whale, if you were tracking a blue whale, presumably you could put pretty big transmitter on that? And it was
We don't go for big mammoths because the only way to attach is with invasive methods. And ethically, we don't want to do that. That's something that the team doesn't want to do. So unless someone develops a good enough suction cup that will stay for more than 2 days, that's the average, 2-3 days.
So the other thing was that I'm hoping to sort of marry the first and the last talk together with this suggestion, okay? So I'll try and be very concise with it, but I'm a very keen forager of wild mushrooms, and over the years I've been taking photographs.
You're a funky geek.
Exactly, my apologies directly. Fungi.
Fungi. You're a fungi.
Anyway, over the years I've been field courses where I've been taking digital photographs. Now the great thing now with my iPhone is that it tags the GPS location of the mushrooms that I find. So I can go back and look at the date, and I can go back to the same spot and know that that fungus is grown there because they'll maintain its soil for 20, 30 years. The other thing that I can find interesting is using Google Maps to actually locate areas, specific types of trees that I know there's going to be things like chanterelles and ceps and good edible mushrooms. Now, with the very sensitive logging data, I could probably tag exactly the spot, square meter, where those mushrooms are, and then also, hopefully, get a drone to come in. Instead of going to visit a location, the drone will then go and find those mushrooms for me and tell me that they're there, and I can go and pick them without wasting a day. So
hack a drone. I think there's so many exciting applications. It's ridiculous, actually. I think we'll all have friendly drones to do our bidding. I can't wait for it. So, do we have any? Sorry, go ahead.
I can add here is that if you use the camera, you will be able to get very close to your previous location, because computer vision is even more efficient than all the other sensors you have on the phone. It can
you can triangulate between different tree stumps and know that it's between certain.
You will estimate the distance much more accurately than within a few meters that you get with sensors.
Do you think we could book truffle pigs out of business? These truffle drones instead.
Yeah, sensors had a
have a little basket hanging beneath the drone.
You've got an artificial nose
truffles.
Build it. Make it happen. Truffles. Cool orchards of truffles in England and France and all over the world, and being able to spot them and detect them. It's a multi-million-pound business, and it's big.
What is it? Truffle
farming.
Yeah, big time. I love truffles.
So a question for Colin. I don't know if he'll be able to hear me.
Colin, can you hear?
I didn't hear the question, no.
Ask a question and I'll relay it to you.
So, can you talk us through the process of developing this company from being drone flying to being a software and data company?
Yeah, so Colin, can you hear me?
I can, yes.
Yeah, so right now you've just got a bunch of guys with a remote control helicopter effectively. And it's a great business, there's nothing wrong with that. You're replacing drones with, what is it, ghosts with ropes? That's not me, that's like a technical industry term. And of course you're transitioning now into a big data analytics company where drones are just simply your eyes and ears to these high value industrial assets. So how do you transition into becoming that sort of data analytics, that high value data analytics rather than just simply a drone company? Is that right?
Yeah.
Yeah, it's a good question. I think it's a bit of a self-fulfilling prophecy in that if you do lots of drone flights, you just produce masses and masses of data. So you have to build a tool that will hold it. So there's companies out there that they're just drone pilots. They don't have inspection engineers. That's an important first step. So actually turning the drone data into business intelligence, into actual actionable information is a key first step. And then once you've been, we've been doing that systematically now for about 7 years, which is a very long time in the drone business. And we've built tools that can automate it. And you effectively when you look at the alternative of sending a guy over a rope or just producing 10 gigabytes of video data and giving it to your client and saying, there you go, pay my invoice, neither of those things are preferable. So if you can handle, if you basically offer a complete drone as a service where the drone flies and at the end of it you get a dashboard with traffic lights on it telling you you do or don't have problems, it just one follows straight after the other. It's really, it's just a perfect next step forward. It's not a challenge to get to that. People it's like the market's pulling it out of us rather than us pushing it.
Okay, I think we're going to wind things up in a little 5 minutes, so 2 quick questions, and then I think we'll end it there. Go ahead.
Hi, my name is Asif. I've got a question for Colin. So with this amount of big data, and as you said, over a period of 7 years, there must be masses of data. So are his clients interested in predicting failure?
Oh yeah, so you're going to be pivoting towards algorithms, presumably, Colin, that do your structural health monitoring, prediction, analysis, hypothesis and diagnosis algorithms. So you can transition from scheduled maintenance to predictive maintenance to predict the failure of a component, a part, particularly if it results in damage to life or high-value assets again. So is that where you're headed? You're using prognosis and diagnosis to predict structural failure in advance of it actually happening?
Yeah, I mean, to be humble about it, I see we probably have to hook into an incumbent, $200 million SAP, system that is getting a lot of sense data back already. I see us as one part of the feed. So if something's vibrating and you've looked at it with a thermal camera and some other information, maybe the actual process condition, the temperature of the fluid going through it or something, when you pull all that together, you can answer the question. And I would love to say that we'll build that, but I think really to be honest, I think the marketplace for Internet of Things technologies is that you have to have your niche and you have to be able to talk to the other people to get the results out. And that's what we're working on at the moment, because otherwise we'd be biting by too much.
I think also there are some major liability issues. I mean, look at Sunset Aviation, allegedly. They were responsible for the prognosis algorithms for HUMS, for rotary aircraft, helicopters.
Yeah.
So, Bond, CHC, Bristow, all those operators that take passengers to and from rigs, oil rigs via aircraft, so that the health and utilization monitoring solutions that are supposed to predict failure using algorithms were failing. Remember in the news a few years ago, these helicopters were ditching in the North Atlantic, and they were experiencing failures based on incorrect information. They had not realized that these aircraft were being pushed well beyond their sort of designed, intended usage, and as a result they were getting all kinds of failures. And the entire fleet were grounded, lawsuits being thrown here, there, and everywhere. So if you're saying, don't worry about it, trust our algorithms, and we think this widget is going to break, and it's got another 10,000 useful hours of life, and it fails, algorithms don't deliver, and then it leads to, like I said, millions of pounds worth of lost productivity, or maybe loss of life. Then you've got to be really sure that your algorithms are going to predict failure without any kind of inaccuracies. Is that a fair point in terms of liability?
Yeah, I mean, it's a really good point. And I think what it points to is that all of this technology is not intended to put people out of work. I think that's a massive misconception of the Internet of Things. And all we're trying to do, in all of these technologies, in all these different, whether it's aviation or oil and gas or energy, we work on a lot of wind turbines and things like that. If you can take away all the grunt, expensive, dangerous hours, but you still have a team with the same size, you can do a lot more with that information that you've got. So in theory, it's not about collecting the data with a sensor and producing a graph and then sacking the guy that used to take those measurements. It's about getting that guy to analyse that information that's being produced. And then, the whole industry be ratcheted up or notched and becomes more intelligent. So it's at the same time there's a scalability issue, but equally there's a huge opportunity for everyone to get smarter, I think. And if people don't get that, if they just replace the checkout girl with a machine that keeps telling you there's an unexpected item in the packing area, then it's not going to be nice for anybody.
So is anyone familiar with the term mixed initiative? There's a lot of empirical evidence to support that high-functioning teams that are just made up of humans or just robots are outperformed by teams that are made up of humans and robots. In other words, mixed initiative, which I think is what Colin's saying, that humans can bring a lot of insight by leveraging the data, and vice versa, robots and AIs, obviously, are not quite as good as humans at certain things, and of course robots are much better than humans at other things. So I think it's a match made in heaven. So let's kind of end it there. You did have one last question. Do you want to make it very, very quick?
Just a quickie, yeah. I'm just wondering whether you're unique in doing what you're doing, or whether there are others doing it, because it seems to me technologically very analogous to what you'd expect people sitting in silos in Texas bombing Syria to be doing.
So I think you're not the only show in town, but I think there is a local competitor who has spoken at previous events, Cyberhawk. But I would say you have a pretty good claim of being the market leader, would you say? I mean, hey, I've got to be impartial here, so it's up to you to do your sales pitch. But what was the question specifically?
Are there other American military spin-offs not doing very similar things technologically? Remote monitoring, machine intelligence, and business intelligence on
Yeah, if you don't have competition in the marketplace, you're in too early. So I would very much hope, because this is a multi-billion-dollar sector. If you didn't have competitors, I would be very concerned, and I'm assuming that you do. And some of the big boys, like Lockheed's and the Thales and BAE Systems, those are the kinds of guys that you'll yeah, exactly. So, I think essentially you've got a legacy issue with the big aerospace and defense companies like Raytheon, and they're from the aerospace industry, so they use jet propellant fuel. These guys are coming from consumer electronics, so gyroscope. Essentially, they're sophisticated flying mobile phones. So you've got two completely different ends of the industry, and the big guys are looking at these more dynamic. DJI, for example, the consumer drone manufacturer, they're going to sell well in excess of 1 billion drones. Now, how many drones will a BAE system sell? Probably that many, but high value. It's a completely different market.
You know the company Boston Dynamics with the robot horses. You know, this isn't just about drones. This is about any robots that monitor anything.
Absolutely, but and culturally, I mean, I go to drone events, industrial drone events, and I can see it's like two schools of thought. You've got the old school incumbents that, like I said, have come from a very heavy industry, aerospace, industrial background, and then the new kids on the block that are using components that have been traditionally found in mobile phones, consumer electronics, all trying to solve similar problems, but from a different kind of perspective. And I suspect probably all the innovation is going on with the startup ecosystem, within the startup ecosystem, and the big guys are just going to acquire them. They're going to wait for the market to mature, and then because they've got big bugs, they'll just start throwing some cash around, and they'll probably end up being acquired by BAE or American.
I was just going to say, I think it's two approaches. One's a technological big dog type approach, and the other one's asset management. And that's a business. The key thing about this is a business approach. It's asset management, it's managing the asset of oil rigs, it's managing the asset of all these windmills out in the middle of the North Sea or whatever. It's a business approach.
When the types of drones are used in Syria, Afghanistan, Iraq, they are not fit for purpose when it comes to these niche applications. They're way too expensive. They need to be in the air for days, I think. And they're, like I said, they're not battery powered. They're using jet propulsion fuel, and they're fixed wing generally. So they're not as nimble, they're not as, like I said, fit for
The DOD
purpose.
in America has been commissioning companies creating little tiny robots.
Microdrones, yeah.
Microdrones
Yeah.
to monitor close up on battlefield.
Yeah, and have you seen the
I know
cost?
what you're saying is right, but they are also into the small
Have
scale.
you seen the cost of those companies? I mean, per drone you're talking about, what, $250,000? Whereas you can easily hack a DJI and do pretty much the same job for under $5,000. So, you know, in terms of economies of scale, all the innovation is happening at the grassroots within, you know, this little ecosystem. But you're right, the big boys are not paying attention to it and discounting it, when in fact, I think they'll be out-innovated. So they'll either be killed off or they'll go through an aggressive acquisition strategy of buying up all these small innovative programs. Anyway, I think we should probably end it there. There is, I think, alcohol left, so it's important that that alcohol is not there by the time we leave the room. Is that fair? David? Yeah? It's there for a reason, right? So let's drink it. Okay, so round of applause for our anyone further than St Andrews? I think you're probably going to take an award for the furthest travel today, so thank you so much, Sergio. Right, drinks. And I don't know if I was going to go to a pub or a bar.
Just to say we've got a hard stop at 9, that's what the door is.
Okay, we're going to throw it down. 10 minutes. 10 minutes. 10 minutes, guys.